Let's look at the warm up where we have line CD, which is tangent to this circle. And as a reminder, if something is tangent to a circle, that means it makes a 90-degree angle with the radius of the circle. So I just drew the radius of the circle in there, and this would be 90-degree angle right here. We also have been told that the measure of arc ABC is 228 degrees. So arc ABC is this major arc here. So it is 228 degrees. We're looking for the measure of angle ACD. So angle ACD is this angle right here. This is what we're looking for. So there's a few ways that we can go about doing this. The first thing that I want to talk about is I can add in more information based on if this major arc is 228 degrees, then I could figure out the measure of this smaller arc AC. We would get that by taking 360 and subtracting 228, which is 132 degrees. So this arc over here, arc AC, which is now a thicker green there, this is 132 degrees. Now keep in mind that if this arc is 132 degrees, then the central angle that intercepts that arc, which is this angle right here, that goes from A to the center to C, so this angle right here is 132 degrees as well. Notice that we just created a triangle. In fact, it's an isosceles triangle because this side and this side are both a radius of the circle, so they're congruent to each other. So because these two sides are congruent, then I know that these two angles are also congruent. So if we take 180, which is all the three angles added up together should be 180. If we take 180 and subtract 132, then we're left with 48 degrees, which means these two angles together total 48 degrees, so each of them is 24 degrees. And finally, this helps us to find this last angle, which is what we're looking for right here. Again, this angle ACD, because I know that this angle from the radius to the tangent is a total of 90 degrees because it's a right angle. So if I'm looking for the measure of angle ACD, I can just take 90 and subtract 24 degrees, which means that the angle is 66 degrees. So this angle right here, let me make it dark so you can see exactly which angle I'm talking about. This is 66 degrees. So angle ACD. You might be wondering where we're going with this, but let's write this up right here. It says compare each angle formed by the tangent line and the chord. So this original chord right here, which is the segment CA, to its intercepted arc. What appears to be true? So the angle that's formed by the tangent line and the chord was this angle right here. And I can see that this angle, it intercepts this arc right here. Again, arc AC. So how does 66 degrees compare to 132 degrees? Well, it's exactly half. So the angle formed equals half the measure, half times the measure of the intercepted arc. That's also true of this angle on the other side. We'll do this in blue, of the chord. So this angle over here, let me highlight the actual angle. So this angle over here, which I just highlighted in orange, if this angle is 66 degrees, then this angle over here, we could take away 66 from the total 180, and this would be 114 degrees. And the intercepted arc of this angle would be this arc over here, which was arc ABC, which we knew was 228 degrees, which is double 114. So again, this angle is half of this intercepted arc. So let's apply that to our notes. It says if a secant, remember a secant intersects a circle in 2 points. So we have this would be your secant. And I would say if a secant, and this could also be, or a chord, so maybe it's not necessarily a line that continues past, but maybe it's a chord. And a tangent, so here's our tangent, if they intersect at a point on the circle, so that means this point right here is the point of intersection of this tangent line and this secant, then the measure of each angle formed is equal to half the measure of its intercepted arc. So what this means is over here, where we have angle 1, this is going to be equal to half of the measure of this arc here. So the measure of angle 1 equals 1/2 times the measure of arc, in this case, that's arc AB. This is the arc that it intercepts. So it goes from the vertex out to where it intercepts that secant there. The measure of angle 2, so here's the measure of angle 2. Angle 2 is right here. I can see that this angle intercepts this arc all the way around the major arc there of the circle. So that means that the measure of angle 2 is 1/2 of this arc. So the measure of arc, in this case, BCA. So 1/2 times that. So let's practice. We are looking in this problem for the measure of angle DEG. So angle DEG, I'm going to highlight right there in the yellow. Well, what we can see right here is this 308 degrees is actually the measure of this arc. We'll use all kinds of colors here. So the 308 degrees goes with this arc that goes from E to H over to G. So that means that if I'm looking for the measure of angle DEG, that should equal half the measure of this intercepted arc, which is half of 308 degrees. So half of 308 is equal to 154 degrees. So the measure of our angle DEG is 154 degrees. The next problem, we're looking for the measure of angle DBC. So angle DBC is this angle right here. Well, I was given the measure of arc BED. So that measure is corresponding only to this arc here that I'm highlighting in green. So we could find the measure of this arc over here in red. If we take 360 and subtract 192, we would get 168 degrees. So I know that the measure of arc DB is 168 degrees, and we could put that right out here to label it. So I know that the measure of angle DBC, again, this angle here, should equal half, oops, that should equal half of that intercepted arc's measure, which is 168 degrees. So the measure of angle DBC, half of 168, is 84 degrees. Let's do one more. If we want the measure of arc XY, so arc XY is this little arc in here. 151 degrees is actually the measure of the angle right here. So this angle, I'll write it down here. The measure of angle WXY is the 151 degrees, which then tells me that the measure of angle VXY we could get by taking 180 and subtracting 151. So that's actually equivalent to 29 degrees. So this angle in here is 29 degrees. So that means in order to get the measure of arc XY, we need to double the measure of the angle because this is the intercepted arc, it's double the angle. So 2 times 29 is going to be what? 58 degrees. I want to cut this video off. Keep watching the next video for me because that's going to go over the back. But just so that this video isn't too long, I'm going to go ahead and pause here, but come back for the second video to finish the notes on the back of your worksheet.